Hey everybody, it's Beej with Lambda School. Today we're going to do a quick refresher on linked lists. So we want to be able to utilize a doubly linked list, figure out what it is, some of the benefits and drawbacks of the list, and how it gets used. So let's start with a quick refresher. We have a regular linked list here. This is the classic linked list that everybody is familiar with. So you have a bunch of nodes here, a pointer to the head node, and then each node has a pointer to the next node along the list. So this is what you're used to. One thing we can do here though, if we want to take it to the next level, is we can make something called a doubly linked list. This is exactly the same thing as we had before. You notice we have a head pointer and we have pointers to the next nodes, but here we've also added a tail pointer and a pointer to the previous nodes. We kind of have two linked lists together over the same set of nodes, one going forwards along the list and the other going backwards along the list. What does this get us? We can traverse the list both directions. We instantly can go to the tail. We have a tail pointer right there. So what used to be an order n operation to scan your way down to the tail of a linked list is now an order 1 operation, because we can just simply go to the tail. And from the tail, we can look backwards at some of the tail elements. Just like from the head, we can look forwards at some of the head elements. So it's a much more flexible version of a list. Another one of the benefits is if you want to delete a node. It used to be in a singly linked list. If you wanted to delete a node, you would have to traverse the list down to the node, keeping track of the previous pointer. Because if you want to take a node out of a linked list, you have to take the previous node and hook its pointer up to the next node, cutting the victim node out of the middle. So you need a pointer to the previous node to be able to do that. So you can set the previous node's next pointer to skip over the node that we're cutting out of the list. So if you can get the previous node another way, then you're in better shape. And here we can actually do that because we have links to all the previous nodes as well as links to all the next nodes. So here, if we want in a doubly linked list to remove a node from the middle of the list, getting the previous node is an order 1 operation. Getting the next node is an order 1 operation because we have pointers from the current node to both the previous and the next. And once we have pointers to the previous and next nodes, cutting that victim node out of the middle is as simple as changing some pointers around. So removing a node from a linked list, a doubly linked list, is an order 1 operation once you have a pointer to that node. Of course, getting a pointer to that node might be a longer operation. If you have to search through the list to find it, that's still order n. But if you have a different way of keeping pointers to those nodes, then maybe you can do it in faster time. But everything is not perfection in the land of doubly linked lists. There are a couple drawbacks. We are using a bit more overhead per node. Before we were just keeping a next pointer along with our data, but now we're keeping next and previous pointers. So kind of twice as much pointer overhead. Not only that, but if we want to manipulate the linked list, now we have twice as many pointers to manipulate as well. Before, we just had to hook up the next pointer correctly if we were going to remove a node from the list. But now we have to keep track of the previous pointer as well, hook that up correctly. If we manipulate the tail of the list, we have to update the tail pointer. There's basically twice as much pointer management. But some of those benefits we get, being able to run from the tail of the list backwards, being able to remove items in order 1 time, good benefits. So here on this slide are a couple challenges. Go ahead and pause the slide here and go and see if you can learn a bit more, do a little bit more research on linked lists. As always, thanks for watching.